All right, now we have a couple harder problems in our topic of solving equations by square roots, a challenge problem on the left and a real-world connection problem on the right. I want you to pause this video, give these a try, and then check back in and see how you did. So let's do the one on the left first, and our job is to solve for x. And let me show you what you might be tempted to do first. You might be tempted to subtract 9 from both sides first to maybe get those constant terms grouped together. Then you'll have an x squared plus 6x equals 25 minus 9 is 16. And then you might be stuck, right? You might be thinking, well, shoot, how could I divide both sides by x? Why did I do that? Divide by x. Well, that gets messy because then we have 16 over x on the right-hand side. There's got to be a better way, and there is a better way. And if you pause and notice, this is what I want you to do a lot in math class. Don't try to rush into a problem. Just pause and notice. See if you notice anything. And maybe you'll notice that that left side is a perfect square, and so is the right side. Okay, and now we can do some good stuff with it. We can square root both sides. And so we have x plus 3 is plus or minus 5. Okay, so now we have two different pathways that we can follow, but the key thing is we did some factoring. We noticed that we had a perfect square to begin with. Okay, so one option is x plus 3 is 5, and the other option is x plus 3 is negative 5. So we can subtract 3 from both sides. And we have on the left, our one final answer is x is 2. And one final answer is x is negative 8. So those are our two solutions. And the big trick there was to realize that we had some perfect squares that we could deal with. All right, let's go over to our real-world problem. Looks like another watermelon problem. Again, I need to say, don't actually do this at home. So I dropped a watermelon off of a 25-story building. And this might be a familiar problem to you. We did it with Desmos before, and now we're going to try to do it by hand. Okay? So under Earth's gravity, the height of a dropped object from an initial height of s feet, and here s is going to be 250 feet, because we have 25 stories and each story is 10 feet tall, can be modeled by this equation. H of t, so the height as a function of time, is negative 16 times t squared, which t is this number of seconds that have elapsed, plus s, our initial height. So let's plug in what we know. H of t equals negative 16 t squared plus 250. And we're wondering how long it'll take the watermelon to hit the ground. So what's the height of the ground? Height of the ground is 0. Okay, and so let's go ahead and solve it. Okay, so we are going to subtract 250 from both sides. Remember, we're trying to get all the t's on one side and all the number terms on the other side. So we have a negative 250 equals negative 16t squared. Looks like we can divide both sides by negative 16. These guys canceled, and we have a t squared equals, what does that turn into on the left? 15.625. Okay, so we need to square root both sides. And we will get a final result of t equals plus or minus 3.95. And so then we need to think about, first off, what units are. Units are in seconds. And then we need to think about, what does the positive or negative mean? Could this watermelon have hit the ground in negative 3.95 seconds back in time? No, it can't. So we are going to eliminate the negative and decide to just choose the positive. So it'll take just under 4 seconds for this watermelon to hit the ground. Don't do that at home though. Okay, that's a good place to stop.